Hello everyone, I will be covering the remaining ladder problems in this video. So we start with this. A uniform ladder rests on a rough ground. When we read a rough ground, that means we have a coefficient of friction on the ground and is propped against a rough vertical wall. Again, same idea. That means we're going to have a coefficient of friction with the wall. If the coefficient of friction is 0.5 and 0.25 for the ground and the wall respectively, this means that this is for the ground and this coefficient of friction is for the wall. Alright, so it means it's in order. Find the inclination of the ladder to the horizontal wall when it's on the point of sliding. So we need to find the angle of the ladder with the horizontal, so basically meaning with the ground. So the first step would be drawing this. So we would have our vertical wall over here and we're going to have our ground over here. Okay, and we're gonna have our ladder, which is from here to here. This is our ladder. Now let's look at our forces. So first thing, we're gonna look at the wall. In the wall, we have a normal force that is going to be in the direction of the ladder always, because it is laying on a flat surface. So there's gonna be a normal force here. I'm gonna call this N1. All right. And we're gonna have a friction force. So if this ladder is sliding, it will slide towards the bottom. So this means the friction will be going upwards. All right, and I will call this FR1. Okay. I'm gonna keep all my frictions and normal force. Everything at this point is gonna be green, so that there's no confusion. Okay. So we're gonna have a friction force going upwards over here. FR1, and the same thing at the bottom. Now when we look at the bottom, we're going to have a normal force going upwards because it is a flat surface, so it's going to be over here N2, and we're going to have a friction force. If this is sliding, it will be sliding towards the right. So if we have a friction force, it is going to be towards the left. Alright, because if this ladder is sliding, it will go towards the right, so the friction is opposite to the motion, which is the left, and we will call this FR2. Okay, now how are we gonna solve this? So first of all, in the question, it does not mention that this is a weightless ladder. So this means this ladder is going to have a specific weight in the middle over here. All right, this weight, and this weight is at a distance of in the middle, which is half of this full ladder. All right, to simplify this equation, what we can do is we can assume that the ladder's length will assume that it's equal to 1 meter. All right, since it's not given. This is only an assumption. Okay, because later on you will notice that it doesn't matter what the length of the ladder is. We only care about our coefficient of frictions, because what we're trying to find is just this angle. So we're trying to find the angle over here with the horizontal. We'll call it theta. This is what we are trying to find. So first we have our mu for the wall to be equal to, mu is equal to 0.25 for the wall. All right, so we can write our equation FR1. Remember that friction. All right, I'm going to use a small f since I always use small f for friction. FR1 is equal to mu times N1. In other words, FR1 is equal to 0.25 N1. All right, so again, just to clarify, from the question, when we're looking at the vertical wall, we're looking at the green part, which is this. And when we're looking at the ground, we're looking at the blue, which is this. All right, 0.5. So mu for the ground, all right, we'll call it mu2. This was mu1. So mu2 is equal to 0.5. And the friction force 2 is going to be equal to mu2 N2. So in other words, FR2 is equal to mu2 is 0.5 N2. So this is the first two equations that you guys should always be getting. The equations for the friction in terms of N. And yeah, so now this was our first step. The second step is we're going to find our sigma fx and sigma fy. Let us assume a positive direction. So I usually assume my positive directions to be to the right and up. So this is my plus x and this is my plus y. All right, let us start with sigma fx equal 0. Okay, because it is saying when it is on the point of sliding, so it's right as it's about to slide. There is no motion yet, but it's almost about to slide, so basically everything is still in equilibrium. So sigma fx is equal to 0. When we use this, we find out that we look at our x forces, we have n1 and we have fr2. Okay, n1 is going to the right, so it's going to be a positive value. So our sigma fx is equal to positive n1, which is going to the right, minus fr2, which is going to the left, and this is going to be equal to 0. So now we can see that we have another equation, which is n1 is equal to fr2. Okay, same thing again, we're going to do our sigma fy. Okay, let me just number my equations. So this is equation 1, this is equation 2, this is equation 3. Okay, now we're going to do our sigma fy. So let me just get this drawing to the bottom so we can look at it again. And I'll make it a bit smaller and keep it here on the side. So again, we're going to do now our sigma fy, which is equal to 0. Sigma fy is going to be, remember, up is positive, down is negative. So we have our positive n2, positive fr1, and our negative weight, because weight is going downwards, is equal to 0. Okay, another way of rewriting this equation would be the weight is equal to n2 plus fr1, n2 plus fr1. Okay, now this will be our fourth equation. So we have our 4 equations. The last equation we need is going to be the moments equation. So sigma moments about any point. We can select either this point 1 over here. So this is point 1 and this is point 2. So we can find the moment at either point 1 or point 2. For simplicity, I'll just use point 2. It doesn't matter which one I use. So I'm just going to use point 2. And the moments has to also be equal to 0. Alright? So the way I will do this is I'm going to have to find my perpendicular distances. Okay? So we're going to have a moment. Obviously, the moment from fr2 and n2 is going to be cancelled out because they're acting on the point itself. So we do not have a moment from the fr2 and n2, but we're going to have a moment from n1, from fr1, and from the w. Okay? So let us find out, using trigonometry, how to determine these perpendicular distances. Okay, so we're going to just look at this again. Remember, we do not care about n2 now or fr2. These are not important. This is our point 2. Okay, this is point 2. We're not looking at point 1 anymore. Now we need to determine our perpendicular distances. So for this w, all right, if we extend this force a little bit, it is going to go up to here, and this is its perpendicular distance over here. All right, because this is going to form a right angle right here with our force. Since our ladder is 1 meter in length total, the weight is always acting in the middle of the ladder, so this is going to be 0.5 meters over here from this point up to this point. All right, which is just half 1 meter. Okay, now we need to find this x value over here for the weight, so we'll call it x of weight. How can we find this x value for weight? We can use simple trigonometry. If we redraw the triangle, it will look something like this, where this is the hypotenuse of 0.5 meters. This is xw, which is our perpendicular distance for the weight. Okay, and we need it in terms of this angle theta, which is over here. And then using SOHCAHTOA, we're gonna find what we need is we have hypotenuse over here, and we have the adjacent to the angle. So we need to use something that has hypotenuse and adjacent, which is our ka, right? So cosine of theta is equal to the adjacent, which is xw, over the hypotenuse, which is the 0.5 meters. Simplifying this equation, we will get xw is equal to 0.5 cosine theta, right? So this is our first perpendicular distance for w. So this is the perpendicular distance for w. Now let's determine the remaining perpendicular distances we have for n1 and fr1. So for n1, okay, for n1, it is going to be this vertical distance over here, because this is forming a perpendicular with this up to the point 2. All right, so this is our perpendicular distance for n1. So this is, we will call this y, which is the perpendicular distance for n1. And we will look at the perpendicular distance for fr1 is going to be this distance over here, all the way to 2. Because if you notice, if we're extending this force fr1 all the way to the bottom, we were gonna get a perpendicular over here. Okay, so this, we will call it x. This entire distance, this orange distance, is gonna be x. And this will be our perpendicular distance for f1 or fr1. Okay, again, this is the perpendicular distance for n1 because it forms a perpendicular with the line which is coming from 2, and this orange one is the perpendicular distance for fr1 because it forms a perpendicular angle with the point 2. Now we can use trigonometry for the big triangle over here to determine both of these angles. So if we just draw this triangle again over here, we know that the length, we assumed it to be 1 meter. All right, this is the length of the ladder. We know that this is our y, okay, and this is our x over here at the bottom. The angle we need is this angle theta. And now we can use SOHCAHTOA to determine both. So using SOHCAHTOA, we can determine both. So let's look at the x value first. So x is an adjacent, all right? So this is our height, this is our adjacent to this angle, and this is our opposite to this angle. So adjacent and hypotenuse is going to be cosine, all right? So adjacent and hypotenuse is going to be cosine. So when we write this equation, it's going to be, again, cosine of theta is equal to adjacent, which is x, over hypotenuse, which is 1 meter. So in other words, if we simplify this, x is equal to cosine theta. Same thing again for y. If we look at y here, y is opposite, and we have the hypotenuse, so we need opposite and hypotenuse, which is the SOH part. So sine of theta is equal to y over y, which is the opposite, over the hyp, which is 1 meter. So in other words, y is going to be equal to sine of theta. Okay, and now we have determined the perpendicular distance for all of them. Remember, this is the distance for n1, and this is, sorry, the top one is the distance for the fr1, and the bottom one is the distance for n1. All right, so this is for fr1. This is the x, which is the orange, which is a perpendicular distance for fr1, and the y is the distance for n1. Now we can plug it into our moment equation and solve. So let us do that again. Moments about point 2 is equal to 0. All right. Let me just take this again over here and bring it down so we can see how it will look like. Okay, so we have our moments about 2 is going to be equal to 0. we're going to start force by force. So let us look at the W first. The W, remember the perpendicular distance for it was the XW, which we found over here. Okay, so this is the perpendicular distance for W. This is the perpendicular distance for FR1, and this is the perpendicular distance for N1. Okay, so for W, it's going to be W times the perpendicular distance, which is XW, or 0.5 cosine theta. Okay, so this is our first perpendicular distance, 0.5 cosine theta. Then I'm not going to put units yet, we're going to look at directions later. So the next moment we have is from N1, and remember for the N1 the perpendicular distance is Y, which is sine theta. And last thing we have is our perpendicular distance for FR1. So we have FR1, and the perpendicular distance is cosine theta, the X. Okay, so cosine theta. And this is it. So now let's look at the directions. So if we look at directions, if we look at here, this graph, so the W, we're just going to draw an arrow and go towards 2. So it's doing a counterclockwise moment, so it's negative counterclockwise. We are assuming that positive is this way, so it's clockwise. We're assuming clockwise is our positive direction. So this is going counterclockwise, so it's negative. So we know that the W is going to be negative. Let's look at FR1. If we draw from the tip to the point 2, you're going to notice it's going into a clockwise direction. Clockwise, so it's positive. So FR1 is positive. Let's do the same thing for N1, from the tip, from the arrowhead to N2. Again, it is going into a clockwise direction. So it's positive. Alright, and all of this is going to be equal to 0. So if I simplify this, we are going to get negative 0.5 W cosine theta plus N1 sine theta plus N1 sine theta plus FR1 cosine theta. And all of this is equal to 0. Okay, we can take the W to the other side and multiply everything by 2 to get rid of this negative half if you would like. You don't have to necessarily do that, you can keep it the way it is. But if you don't like to deal with decimals, you can do that. I will just keep it the same way. I will just move the W to the other side, so I will get N1 sine theta plus FR cosine theta is going to be equal to 0.5 W cosine theta. Alright, plus, because we moved it to the other side. And this is our last equation, which is equation 5. Now, the most difficult part, I believe, for people is when they come to the substitution. So let us do that instantly now. So I'm just going to copy all my equations down here that we have determined. So we have FR1 equal to 0.25 N1. We have FR2 is equal to 0.5 N2. Equation 3 was N1 is equal to FR2. Equation 4 was the sigma Fy, which is W is equal to N2 plus FR1. And the final equation we got was this one, which is N1 sine theta plus FR1 cosine theta is equal to 0.5 W cosine theta. So these are the 5 equations we have. The first thing we simplify is using the first 3 equations, okay? So we are going to keep everything either in green or in blue so that it makes it simpler for us. So the way I usually do this is I would substitute N1 everywhere. I would get rid of all the frictions, and that would simplify everything for me. So how do we do that? So for FR1, it's equal to 0.25 N1. We'll keep it the way it is. Equation 2, for now at least, equation 2, FR2 is equal to 0.5 N2, and we know FR2 is equal to N1. So using these two equations, I'm going to substitute FR2 here. I'm going to substitute N1 in its place because they are equal. So we're going to get N1 is equal to 0.5 N2. All right, 0.5 N2. This is the first substitution I do, so that now I have a direct relation between N1 and N2. Okay. The first equation, I will just rearrange it. This first equation, I will just rearrange it so that it's in terms of N1. So N1 is equal to FR1 over 0.5. That is all I'm going to do so that I have a simpler equation later on. FR1 over 0.25. Okay. Now that we have done this, we can do the exact same thing again over here. Okay. We can substitute equation 1, FR1, into the FR1 over here. So using this equation, FR1 can be substituted into this, and FR1 is 0.25 N1. So we will have W is equal to N2 plus FR1 is 0.25 N1. Okay, and if you notice here, again, we have N1. We already have N1 in relation to N2. So I'm going to be substituting this again. I will be substituting this N1 over here again. Okay, and this will give us, so if we look at these two equations, this will give us W is equal to N1 is N2, first of all. Let's write the equation. So we have N2 plus 0.25. N1 is basically 0.5 N2. All right. So this is the method I will always do for substitution. I will always get rid of my FR1s everywhere. So I will only have everything in terms of N1 and N2. That way it will make it so much easier to simplify. Now if you notice here, we have just an equation of weight and N2. Okay. I'm going to bring this equation down here. Let's simplify this a bit more. This is just going to be N2, W I mean, is equal to, W is equal to, if I grab my calculator, 0.25 times 0.5, it's going to be 1 over 8 plus 1, which is 9 over 8 N2. All right. All I did was I multiplied the 0.25 with 0.5 and then added 1 because this is 1 and 2. So I get 9 over 8 N2. And now we have a formula for W and N2 directly. We are going to do the exact same steps all over again for FR1 over here. Now we're going to look at our last equation, which is this equation. Okay. Let me bring it down. So we're going to substitute everything, all the equations that we've seen here, where we only have N2 in it, so that we can get a final answer with just N2. All right. So we know that N1 is equal to 0.5 N2. So we're going to substitute into this 0.5 N2. Okay. Same thing here for FR1. We know that FR1 is equal to 0.25 N1, and we know that N1 is equal to 0.5 N2. All right. So instead of this equation, I should have wrote it this way. FR1 is equal to 0.25 N1, which is 0.5 N2. All right. This is how I would do my substitution. Again, all I did was I plugged this value in for N1. This whole value now we can use again to plug into FR1 at the bottom here. So FR1 is going to be 0.25 times 0.5 N2. So 0.25 times 0.5 N2. Okay. And for W, we are also going to do the same substitution. Now we have W is 9 over 8 N2. So we're just going to put 9 over 8 N2. So if we rewrite this equation now, we're going to have 0.5 n2 0.5 n2 sine theta. All right, plus fr1, which is 0.25 times 0.5. I'm just going to simplify that. 0.25 times 0.5 is 0.125. So 0.125 n2. All right, again, don't get confused. This, I just did the multiplication and I got 0.125 n2 cosine theta is equal to 0.5 w. W is 9 over 8, so 0.5 into 9 over 8 n2 cosine theta. Cosine theta. All right, let's simplify all the n2s here and try to group them up together. So this is what's going to happen. We have this cosine, we will take it to the other side, and here we're just going to simplify this a bit more. So we're going to go step by step. Again, 0.5, I'll just copy paste this so I don't have to rewrite everything again, and I will show you how I will do the simplification. All right, so first I'm gonna take my n2s all, and I can cancel them out directly, but first let us simplify this. 0.5 times 9 over 8, so 0.5 times 9 over 8 is 9 over 16. So this is gonna be 9 over 16, or 0.5625 n2 cosine theta. All right, if you notice, we have n2, n2, and n2 everywhere. We can straight up just cancel the n2 completely from this equation, because we have n2 in all of the places. Yani if we take a common n2 on the left side and then divide the equation by n2 left and right, we will be canceling n2. So we can get rid of n2 everywhere. All right, the way you will notice this is if you're dividing by n2 left and right, by n2, you will notice that these all cancel out. Now, what will we be remaining with? 0.5 sine theta plus 0.125 cosine theta is equal to 0.5625 cosine theta. Okay, this is what we will be remaining with now. So now we have an equation with only theta in it. Let us group the cosines together. So we're going to have 0.5 sine theta is equal to, we're just taking this cosine to the other side, 0.5625 cosine theta minus 0.125 cosine theta. All right, all I did was I just rearranged, and now we can simplify the right hand side. So 0.5 sine theta is equal to, if we simplify this, so 0.5625 minus 0.125 is equal to 0.4375 cosine theta. Now, an important rule you should remember that tan, in your trigonometry, so tan theta is equal to sine theta over cosine theta. Okay, so tan theta is equal to sine theta over cosine theta. So if we divide both sides by cosine theta now, so if we divide left and right, if we divide it by cosine theta, divide by cosine theta, you will notice that cosine thetas will cancel on the right, and on the left we will have 0.5 tan theta is equal to 0.4375. Now we can divide by 0.5 both sides, so that I can get rid of the 0.5 over here, and we will remain with tan theta is equal to 0.4375 divided by 0.5. All right, so 0.4375 divided by 0.5, that is 0.875. So tan theta is equal to 0.875, and simply here all we have to do is tan inverse so that we can find our theta. So theta is going to be equal to tan inverse of 0.875. So theta will be equal to 41.19 degrees. And this is how it will be for question 2 of the ladder problem.